Hello, my name is Darryl Smith. I am the Chief Data Platform Architect within Dell IT and a distinguished engineer within the Dell Technologies. And I'm going to present to you how Dell IT provides analytics and AI in a massive data lake. And when I say massive, you can see from the numbers, this is not small. We've got about 12 petabytes of data that's active. Obviously, we have a lot more that's older and archived, but that includes 2 petabytes worth of relational data and about 10 petabytes of semi-structured and structured data. And we have a lot of different technologies that support these tools, and I'm going to show several of them to you. Um, but how do we start to grow? How can we make this more productive? And really the key to a successful data lake is to enabling self-service. Allow the users of the platform to be able to get their own services, get their own products, gather their own data. Because if you've got IT in the loop, that's going to be your bottleneck. It's going to really slow down and make your data lake a lot less effective. So how do we do that? Well, we provide the ability to provision your own workspaces within the Greenplum, the Teradata databases, the Hadoop platform, various other execution tiers, which I'll show you later. So you can stand up your own infrastructure. You can also go and find your own data and get access to it all through without getting anybody from IT involved. So we have a catalog, and that catalog is currently running in Calibra. We're likely going to move to Elation, but essentially the goal of that is if I'm looking for data, let's say the marketing version of customer, I can go into the catalog, I can select under customer, under marketing, search for customer, find the data elements, the data domains that I'm looking for, push a button to request access to them, and then that access goes through a workflow where the data steward who owns that data has the ability to grant you access. And then once that workflow step has been completed, that access will automatically get granted to you, and you'll receive an email saying you've been granted access to this data, and this is how you get to it. Within that data, and as part of that data catalog, we've got a lot more information to help you discover if that's the data that you're looking for. So we've got lineage, where did the data come from? What's processing steps have been added to it along the way? And then we've got various data quality metrics to tell you whether or not that data set is ready to go or may need some additional work to get it to the level of quality that you need. So that's getting your data. We call that data ops. So you can get your infrastructure through the provisioning forms that you saw on the prior page, and you can get your data through the data catalog, all without having to engage with IT. The second thing that you really need is to more than just one technology. So a lot of people started off building data lakes with a Hadoop environment or with an Oracle database or some other technology that doesn't really scale for what you need. It doesn't scale for the velocity of the data that's coming in, but more importantly, it doesn't scale for the velocity of the data going out. So you can see from our platform here, or platforms, we have a lot of different tools that we use. So for our data lake, our goal is to get our data as quickly as possible. So if we could stream every single data bit in, we would. We can't always do that, but we use tools like Oracle Golden Gate or Informatica to go query the data that's out in our enterprise. We also have data sets that are coming from externally, like social media and our IoT or our devices that are out in the field. But they all come in through the same pub/sub framework. We persist the data onto Kafka, and then we use stream sets or Greenplum GPSS, or now Teradata also has a direct connect to Kafka, where we can pull the data directly into our shared data platform. So our shared data platform is where all of the raw data goes. So it's in its native format, where it exists out in the world, whether it's in an enterprise system or out in social media, and gets stored in the same exact format. The reason that we do that is we've got a lot of domain knowledge. And so we've got people who understand those schemas. And if we were to change them, we would lose that knowledge. Additionally, if you're talking about machine learning and in some analytics levels, they need the raw data. It's very difficult to do machine learning off of an aggregated data set. And so we persist that data in its raw form. Obviously, we then process it, especially for analytics, to make reporting easier, to make what if queries, what if analysis type easier. And in addition, in some cases, we have to merge multiple data sets together because we've got multiple ERPs, multiple manufacturing systems. We need to merge them together so that when you're doing machine learning, or if you're doing analysis, you're doing it off of a single data set and not doing it off of multiples and then trying to aggregate the result sets, which is never very successful. So built on top of that, across the top, we see the services tier. We've got several technologies that we utilize there, but essentially it's all built with microservices. And what happens up there is typically our eventing models. And so we'll have applications or microservices that are subscribed to the data topics within Kafka. And as those events come through, they get measured and queried and analyzed to see if there's something that should be done. So does it indicate, hey, we need to order this new widget, or do we need to send an email notification to a customer, or do we need to send a follow-up sales visit? So we're mining that data as it comes into the data lake for individual actions that should be taken, as well as persisting into the shared data platform. To the right of that, we have what we call an execution tier, and those are database tiers or data platforms that are designed for consumption. So I mentioned we need to be able to consume the data in very, very rapidly, a very high velocity of different types of data sets. And that's all well and good for the shared data platform, but to try to report out of that or to try to build predictive type applications, we wouldn't be getting the performance levels that we need. And so that's why we stand up these data platforms that are designed for consumption. And then obviously they're accessed from various consumption tiers from, excuse me, reporting tools, dashboarding tools, applications, as well as the data science tool set, which we'll take a look at in a moment. So when we look at data science, we have 5 different platforms. If you recall from the initial slide, I have 2 of them shown here. We have a very formal data science platform. It's called the Cloudera Data Science Workbench. And these are some of the capabilities that we have within that. So we've got a vast amount of packages that we can utilize. We can pretty much connect up any editor to that, certainly any editor that supports SH. Various languages involved. We have machine learning as well as deep learning libraries. And we have similar type capabilities within what we call an innovation platform. And we call it that because it's built off of PKS. It has the ability for you to deploy any container that you want in support of your machine learning. And one of the things that we found is that data scientists tend to bring a lot of different tools in, a lot of open source tools, a lot of tools that they've used elsewhere that we don't necessarily support today. And so they can put them into that cluster, which is protected by NSXT. And so we're allowed and we're able to put, pretty much any kind of technology we want in there without having to get into too much trouble. And once they've got their model trained, or once they've decided, hey, I want to be able to use this technology, this particular package or workspace that's not currently supported, we can then make a plan to get it supported into the fully supported platform, Cloudera Data Science Workbench. We also have built right into Greenplum itself the ability to do machine learning as well as deep learning. And so it's if you happen to be able to utilize an algorithm that's within MATLib, you can run it right off of the data directly into the database versus doing your data discovery within Greenplum, extracting your file out, and then doing your modeling and your training outside in a different tool. So just a few options because we try to give you every opportunity to be able to use what works for you. Next up, you really need the right hardware. If you're trying to build this stuff on, say some weak application tiers, along with some very, very poor storage, or you've picked the wrong infrastructure, your performance is going to suffer. And if it takes you 2 weeks to get your data set out instead of 2 minutes, your productivity is just going to go down the hill. So one of the things that we're very careful about is standing up infrastructure that can perform, and at the same time being very agile so that we can go in any different direction we want. So the bulk of all of our platforms are virtualized within PowerFlex clusters. And so it's very easy for us if we need more stream sets nodes, more Kafka nodes, if we need to stand up another execution tier, we can stand it up within those clusters. They're built off of standard servers. And so as I start to run low on resources, I can just order 3 or 4 more or 5 more or even a rack full and just stand them up. It's plug and play. And so we're very, very quick to be able to scale. and then at the same time are very, very quick to be able to respond to the different requirements, such as expanding a database or adding a new database. And then even our Hadoop is virtualized. So all of our compute nodes run within the same PowerFlex clusters, but we use HDFS for on PowerScale for our Hadoop file system. This allows us to separate our compute and storage and allows us to do a bunch of other things, such as provide archive for our databases utilizing the HDFS protocol. It also allows us to do backups, allows us to replicate the different data centers. And so again, it's all about the agility that we've built into this, but at the same time, giving us the performance levels that we need to be able to very quickly respond to our data insights or new data sets that we bring in. And then over on the right-hand side is our Greenplum database, which was built entirely for speed. With our 56 nodes that we currently have in there, we're capable of doing a terabyte per second of I/O, which really brings those queries really, really fast and keeps those data analysts or those data scientists very actively able to get their data out very, very quickly. And the last tip I want to share is, as you build your data lake, you're not going to build it full size day one. You're not going to have the CapEx. You're not going to have the desire to do that. And so you can build these out small. Because we built these all modulars, we started out small. We started out with just a few PowerFlex servers, a few Isilon nodes, and a few Greenplum nodes. And as we grew and over time, we just added more infrastructure to it, added more nodes in PowerFlex, added more PowerScale nodes, and added more nodes in the Greenplum. And as we did, our speeds went up and our ability to innovate went up. We even introduced a GPU cluster, again with the PowerFlex nodes, which allowed us to move our workloads, or specifically data science workloads, to either the CPU cluster or the GPU cluster based on their need. And then we continue to grow to where you can see we are today, and we're growing well beyond this. For instance, we're going to migrate Greenplum to 128 nodes. So that'll be a 2.4 petabyte database running at 2 terabytes per second, which is quite fast. The last thing I'm going to leave you with is a few key takeaways. Basically, we're using HDFS on PowerScale, which is allowing us a lot of capabilities and agilities. As I mentioned, we can do snapshots hourly for our Hadoop environment. That's more than you could ever expect to do in terms of trying to back up your Hadoop system. Most people don't even do that. And then by providing that HDFS protocol right within PowerScale, I'm able to use that to archive some of our more expensive relational databases onto the HDFS while still being able to access it within the RDBMS. And then building out on PowerFlex with modules that are identical, servers that are identical. As I need more resources, I just simply order more of the same exact server. And because they're PowerFlex, they just plug and play right in. And so, within 3 weeks of needing that infrastructure, I can be plugging more in and always stay ahead of the needs that I have, so that I've always got resources available in the cluster to be able to adapt and change and move in different directions. So that's all I have. I hope this was helpful for you guys. Remember, there's just a few key tips that we've gotten here. Don't try and do everything with one technology. Start small and grow. Provide for self-service. That is probably one of the most important ones. And start today. Don't start tomorrow.